Hi friends, this is Selvin here. Welcome to my networking channel. Hope all are doing good and safe. And today the topic I'm going to discuss about BGP attributes, which is used to control the routing updates. And by means of BGP attribute, we can either influence the inbound or the outbound path or the traffic. So these attributes always show up in the BGP routing table or the BGP table. So let us discuss each and every attribute one by one. The first is a BGP well-known mandatory attribute. So this attribute always present in the BGP table. That is the reason we call this a well-known mandatory attribute. The first is an AS path, next hop and origin. And what about well-known discretionary? Just opposite to mandatory. This may or may not present in the BGP table or the BGP update. So the first is a local preference and second is an atomic aggregate. So third is an optional transitive. Transitive means this attribute we can pass it to the BGP neighbor or the BGP peer or to all other BGP peers. So that is the reason we call this an optional transitive attribute. An example is aggregator and community. And for optional non-transitive attribute, an example is MED. So let us discuss each and every attribute one by one. So the first one is AS path. So AS path is a well-known mandatory attribute. So whenever the BGP router sends an update to the neighboring router, it prepends its AS number to the path. So in this router, you can see the path as 1, 2. So this AS path lists all the ASs that it has traversed to reach the destination. But by seeing the path, you can see what are the list of ASs that it has traversed to reach the destination. And another thing, BGP always prefers the shortest AS path to reach the destination. And another key point is whenever the BGP router receives an update from the neighboring router, and if it sees its own path in the neighboring router, it will just discard the update. So this is a way of loop prevention mechanism. And what about the next hop attribute? So for EBGB, next hop is the IP address of the neighbor that sent the update. This both the router are in a EBGB, right? Both are in different autonomous system. So for this router, next hop is the IP address of the neighbor that sent the update. And for IBGB, the next hop advertised by the EBGB will be carried inside the IBGB. That means from this router perspective, you will see this interface as a next hop interface, which should not be the case. From this router, you have to see this interface as the next hop to reach this neighbor, right? So for changing that, we'll use the keyword next hop self. So this next hop video I already explained in my previous video. You can also please have a look on it. And the third one is origin, so which defines the origin of the route, whether the route is advertised by IGP or EGP or via redistribution. So if I'm using a network command to advertise any networks via IGP, you can see it as I. I is indicated as the origin attribute where the route is advertised by the IGP, and the route is advertised by a EGP. So EGP is a old historic routing protocol. Since it supports only classful routing and it is not supported on the internet, you can't see this attribute in the BGP table. So you can see only the attribute origin attribute IN question mark. So question mark is nothing but a incomplete. That means if it is advertised via redistribution, so if it is advertised via some other routing protocol into the BGP, you can see this as an incomplete or a question mark in the origin attribute. So if you are doing a show IP BGP, you can see this origin attribute, both IGP or question mark. That is nothing but a incomplete. That means the route is advertised via redistribution from some other routing protocol. And what is local preference, which is sent to all the routers in the same IBGP environment, right? These are the three routers. So this router has established an EBGP neighbor relationship with these both the routers. So for local preference, which always sent to all the routers in same IBGP environment, and which is used to influence the outbound path or the outbound traffic from an AS. Always used to influence the outbound traffic, and always the highest local preference is preferred, and the default value is 100. And what is atomic aggregate, which is used for route summarization or route aggregation? So what is an aggregator? It is a router which performs a route summarization or route aggregation. So what is the community attributes? So community is used to tag the routes with an indicator, and is also used for filtering the incoming or the outgoing routes. So there are three types. One is an internet, which is used to advertise the prefix to all BGP neighbors, and second is a no advertise, which will not advertise any update to any BGP neighbors. That means any IBGP or a EBGP neighbor. And third one is no export, which will not advertise any update to any EBGP neighbor. So let us discuss the community type. So the first one is no advertise, right? These are the four routers I connected. These both the routers are in a IBGP environment, and this router has established an EBG relationship with this router since both are in the different autonomous system. Assume this router sends an update. If it is an advertising prefix, say 1.1.1 to this neighboring router, and the same prefix will show up in this BGP table. But this same prefix 1.1.1 will not show up in this BGP table or in this BGP table. So that is the purpose of no advertise. That means which will not advertise any update to either this IBGP neighbor or the EBGP neighbor. So only you can see the prefix advertised in this BGP table, but either we can't see the prefix in this router or in this router. So that is the purpose of community no advertise. So that means which will not advertise any update to either the IBGP neighbor or this EBGP neighbor. And what about community no export? That means which will not advertise any update to any EBGP neighbor. So that is the difference between no advertise and no export. So in this case, assume this router is sending an update. Say prefix is 1.1.1. It is advertising prefix 1.1.1 to this neighboring router. The same prefix you can see in this BGP table and in this BGP table, since both are the IBGP neighbor, right? But the same prefix it will not show up in this BGP table. That means which will not advertise any update to any EBGP neighbor. But the same update will show up in the IBGP neighbor, but it will not show up in the EBGP neighbor. So that is the difference between community no advertise and community no export. So what is MED? MED is a multi-exit discriminator where MED is always exchanged between the different autonomous system or the different EBGP neighbor. And MED is used to influence the inbound path into an AS. So that is the difference between local preference and MED. So yeah, in local preference is used to influence the outbound path or the outbound traffic from an AS, but MED is used to influence the inbound path into an AS. So that is the difference. And MED always the lowest MED is preferred and the default value is 0. In case of local preference, highest is preferred and the default value is 100. But MED always lowest is preferred and the default value is 0. And what about weight? Weight more or less works like local preference. The weight always highest weight is preferred and weight is not exchanged between the routers. Weight is always sent to all the routers within the same IBGP environment, and it is also used to prefer the outbound path or the outbound traffic. Same like local preference, right? So local preference is also used to prefer the outbound path or the outbound traffic. Same like that, weight is also used to prefer the outbound path or the outbound traffic, and the weight attribute is not exchanged between the routers, means it is always sent to all the routers within the same autonomous or the IBGP environment. And weight is a Cisco proprietary attribute. And what about AS path prepend? So by prepending multiple AS number within the AS, it is always applied to outbound path, indicating the best inbound path. So it is more or less like MED. MED is also used to influence the inbound path, and AS path prepend also we can influence the inbound best inbound path. So how we can influence? By prepending multiple AS number, right, within the AS. That means assume if I want to make this path as a best inbound path, I can prepend its own autonomous number. That means I can prepend the multiple same autonomous number 111. So what happens? This path will be less preferred and this path will be more preferred. So that is the purpose of BGP AS path prepend. By prepending multiple AS number within an AS, and it is also applied to outbound in dictating the best inbound path. And also BGP prefers always the shortest AS path to get the destination. So if I'm preparing multiple AS number, what happens? This path will be less preferred and this path will be more preferred, and always it will prefer the best inbound path into an AS. So that is the purpose of AS path prepend. So what about BGP path selection? BGP always prefer the path with the highest weight, and with the multiple routes with the same weight, it will always prefer the route with the highest local preference. And if the multiple routes are the same local preference, then it will prefer the path that was originated by the local router. And if none of the routes originated by the local router, then it will prefer the route with the shortest AS path with the lowest origin code, and then it will prefer the path with the lowest MED. So always try to keep remember at least the first 5 points, right? That's the main point you have to understand about the BGP path selection. This is a path selection algorithm BGP always use for selecting the best path. So this is the purpose of BGP attributes. So the summary is BGP attribute is used to control the routing updates. So by means of BGP attribute, you can either influence or inbound or the outbound traffic. I hope you understand and enjoy this video. Thanks for watching. Please subscribe me for more videos. Thank you and have a wonderful day.